Well, good day, everybody. My name is Alan Feuer. I am your instructor today. I am based in Greater Albuquerque, New Mexico. We'll talk about that in a few minutes. And here's some contact information for you if you would like to capture that. I'll present this, a similar slide to this at the end of our presentation today. I do want to thank all the folks at Purdue University for having me out, for helping me get this recording done for the virtual presentation. And I'm looking forward to our Q&A live when that occurs. Thank you. So here we go. The name of the course today, it was assigned to me, is called Identifying the O of Wood Destroying Organisms. And that's fantastic, but I decided to change the name of the class to this. And because I think this is where we want to go. I want to talk to you guys of the issues that we get when we have water problems that give us fungi and decay rot, and then the bugs that kind of follow up based upon that. So that's going to be the core of my course. We're going to talk about some unique things maybe you've heard of, maybe you haven't, but my goal is to teach you something about all of those things today, okay? So shocking news, we're not going to be talking about termites in this class. I may talk about them in passing or in relationship and connection to the things we're going to talk about, but we're not going to be teaching you about termites. I do pray that you've learned about them. And if you're new to pest management and this is your first conference, well, that's great. Purdue's a great place to be overwhelmed at the beginning. But I hope that there's people in your life that can teach you about subterranean termites at another time, or maybe there's another instructor during this course. But mine's going to be a little bit more unique today. So here are our class rules. And as we're dealing with this in a virtual setting, I'm not worried about any questions and rabbit trails during the class. We will have a question and answer session live tied to the end of the virtual session when I'm actually at Purdue University. If you've got a camera, feel free to take pictures of my slides, or if you want to screenshot any of the slides, that's fine. On my Mac, it's Shift Command 3. And if you've got a non-Mac computer, you're on your own because I have no idea how that works, okay? If I go too fast for you guys virtually, you'll have to rewind the recording and listen to it again. I will try to have a good mannerism to my speech, slow myself down. I usually rapid fire because we do have a lot of stuff to cover today, and we will be proverbially hauling ass through this class to get this in our hour allotted time, okay? I do like to give you perspective, at least how I see the world, how the world in pest management comes to me. So I live in Greater Albuquerque. It's a suburb on the northwest side of the city. And this is more or less a picture from my backyard enhanced with altitude by my son's drone. And what we're doing is we're looking east across the Rio Grande Valley, which is the laughable little river that runs through the middle of our state. And those are the Sandia Mountains, which means watermelon in Spanish. And you can see why they may be called that because of the beautiful pink color they get at sunset. And they are part of the Southern Rocky Mountain chain. So that's where we're looking. If you look to the right in the back of the picture, you'll see part of the city of Albuquerque. And to the screen to the left, which you wouldn't be able to see, is going to be our capital city of Santa Fe to the north. I like to add a little bit of a idea so that you know what we're looking at. I live at about 5,200 feet, or mile high, if you will. And those mountains in that image are 10,400 feet. Santa Fe is at 7,000 feet. And as you can see, it looks kind of brown and dry. And that's a fair estimation of where we live. It's high savanna. It's not desert. But if you can see, we've got a river valley not far from where I live. And by the way, that picture from the image of my home to the Sandia Crest is about 15 miles. So that's you got 15 miles of clear skies to see that. On a clear day, we can see 50 or 60 miles of reasonable elevation. You can also see the green areas, and this is not enhanced in any way, but these are the higher elevations, the mountains, and we have a fair amount of coniferous forest, which are going to be our needle trees, some junipers and things like that, but we also have some aspens and other deciduous trees that we'll see as well. And that's all important to the perspective of the environment that I teach this class from. It's a far cry, certainly from central Indiana, and certainly a far cry from Florida or Alabama. Just for fun too, I'm a huge history buff. We actually had 2 Civil War battles of significance in New Mexico. And if you come visit, I'd be more than happy to tell you more about that. But anyway, going to the almanac and understanding the environment is important when we start talking about wood destroying organisms. And so I've got this chart up here. It's quite a mess to look at, but I've summarized it at the bottom. And I want you guys to understand that as of 2020, our annual average precipitation in Greater Albuquerque was 9 inches. And I tell people we typically have between 9 and 14 inches of rain and snow precipitation. And once we get to elevation in those green areas in that top-down image, we probably double that easily to 18 to 20 inches of rain. So therefore, there's a higher proclivity to have some of our wood pests. We've got them all in Albuquerque, so it all happens. And what's great about us is it doesn't get super hot and doesn't get super cold. So as far as temperature, it's temperate and enough moisture, specifically when the humans, that's us, we add moisture around our home as we irrigate and water things, or we do silly things with water drainage around our house because we take the dryness for granted. Okay. I do like to cite my source materials in the introduction here. Here are the 4 key books that I took this information out of over the years. And the one that I really like to highlight is the one on the right there. And I brought it up into this next slide. And that's the Wood Handbook from the U.S. Forest Service, USDA. Wood is an engineering material. This is a free download. Just type that in, look for it on the internet. You'll find it. It's a free download. So it's a public document. And I like to point to chapter 14, and I've highlighted a couple things. We're not going to look at this specifically today, but a lot of what I talk to you comes right out of this book, and it's agreed upon with Truman's and Malice and the NPMA Field Guide. So I'm not going to give you guys anything that's not been scientifically backed up. I will give you some stuff that the books don't have that I've come into experientially, and it's the value of these classes as I'm sharing my experience with you, okay? So let's take a look at a brief biology of wood. So I think it's a good place to start. We're concerned about wood-destroying organisms, but we should understand why they have the relationship that they do with wood. The majority of wood is simply made out of the organic elements carbon, hydrogen, and oxygen. And if we think about that, where do we see that? Well, we have water's H&O, and carbon dioxide, which is what we breathe out, which we've decided is a greenhouse gas. And that's a whole debatable situation as far as what are appropriate levels. But we know that carbon dioxide is food for trees. So they take water, H2O, combine it with CO2, and they use that to build sugar chains. So that's something we need to understand. Maybe you remember that from high school science, but it's definitely worth understanding. As we take a look at a tree, and trees are all a little different based upon, the species of tree, where it's growing, how much sunlight, how much water. For the most part, there's progression of sugar chains starting with starches, which then are going to be remanipulated by the tree's biology into cellulose, and then remanipulated again over time into lignin. So those are the 3 key components of trees that we see as it goes. So the starches start in the cambium and are found greatly in the sapwood, which is living. Cellulose is going to be in sapwood, a little bit less in the heartwood as it's being lignified. And the heartwood has a lot of lignin. There's going to be some cellulose in there as well. And that's some important points. If you've not understood that about how a tree develops when we take it for lumber and use it as a building material, this is important to understand. I really want you to understand, at least to get a real basic image, the white stuff in wood is cellulose and the brown stuff in wood is lignin. And when that stuff's smashed together, we kind of get that yellowish, really light brown color that we see that most wood is made of. Obviously, it's going to vary by tree, by species, and things like that. But for the most part, that is fair to say and true to say about all trees that we deal with. So if we had to take a couple of notes on cellulose, what I want you to think about, the key fiber of the wood structure is cellulose. And if you want to understand what cellulose is in its raw form, picture a cotton ball, or if you're wearing a cotton shirt or any cotton clothing, it's fibrous, it stretches a little bit, left, right, up and down, but also it can't bear any weight. It has no structural integrity by itself. And that's how cellulose works. We also know that if you were to take a piece of cotton fabric and lay it down or put it over the edge of a cup, and we'd watch the water climb up that cellulose, that's that hygroscopic action where it moves water very well. Basically, the cellulose fibers bound together in a tree make the tree a giant straw. Even when it's dead, it wants to suck water into it. So let's keep that in mind about cellulose. As far as the predation of cellulose by termites, other wood insects, and fungal decay, is that there has to be a value for them to take cellulose. Cellulose by itself it's an insoluble fiber. So if we were to eat it, we can't digest it. Ruminants can, but they do that with the help of bacterium and other small microorganisms in their gut. We, as a single gut animal and things like us, can't digest paper and wood and even like grass very well. We just don't do it. So when it comes to insects, some of them hold internal colonies of microorganisms in their hind gut. Termites come to mind first. And then as far as decay rot and fungi, they'll use enzymes. They'll basically put enzymes on the wood, and then they'll actually consume the enzyme weakened wood, which is now, again, some sort of a sugar base that they can actually consume. So that's important. Now, lignin is a binding polymer. It binds up with cellulose to provide rigidity. And by the way it's set up molecularly, it's relatively hydrophobic, which means it pushes away water. So it rejects moisture. So what happens as a tree gets older becomes more lignified. So we hear the term of old growth forest. So old growth forest had a lot more lignified wood, a lot more lignin in the wood. Therefore, we had a lot more resiliency from the attack of decay fungi and insects. Unfortunately, over the last 60 years or so, we've been using a lot of younger growth forest or forests that we've cultivated agriculturally, if you will, to give us lumber. And so we have a lot of high sugar, high cellulose lumber, and all of these organisms just love it. Okay. So older growth, we call it rough cut dimensional lumber that you might see in older homes, which I see in some of the old, by the way, all you Easterners, we had some civilization here well before you guys can even talk about Plymouth Rock. Okay. So we'll that's a whole nother thing. We'll fight about history later on, but we've got man-made structures, and we're talking European development going back to the 1500s. And we've got existing structures that I look at from the 1700s, or at least they've recovered it and reused some of the lumber that's 300 and some years old, and it's doing really fine as long as it's not like absolutely just sitting on the earth. So that's cellulose and lignin. They bind together, and that's what gives us our tree. Finally, we have sugars and starches within the cell wall. That's going to be quick, ready energy up and down the xylem and phloem, gets saved in the roots during the wintertime, comes up, creates, gets all the energy moving up and down. And if we have organisms that cannot digest the cellulose and lignin, which is a rare event, we actually will see damage to the structure merely because these organisms, insects or decay, are coming after the sugars and starches only. We still get damage because they poop it out as frass, or we see discoloration with the energy exchange with fungus. And we'll talk about that in a few more minutes there. So let's go ahead and talk about decay rots mostly. And again, I'm going to keep pointing back to the NPMA field guide. I really believe that you guys should reference this after my class and make sure that I'm not full of crap. I think you really want to check the information that you're getting. So let's just go to that. Okay. So when we think about non-insect wood destroying organisms, decay, rot, and fungi, they're plant-like, but since they lack chlorophyll, that was their natural development in low light situations. They have to therefore predate on organics just like we do. So this is kind of a predaceous plant if you want to kind of tie it in that way. This is a really good textbook image. I believe this is in a couple of my textbooks, but I don't recall which one I'm pulling it from. So you guys might run into this one. I like to start in the lower right corner as far as what's the life cycle of fungi. And what we see is we have airborne spores. I mean, they're not airborne because they fly. They're airborne because they're always around us, and they're very light and they're very small. They land on moist wood, they germinate like a plant, and then they move their little, filthy little fungal fingers called mycelia through the cell walls, and then they start to do an energy exchange. I'll take what I want, and when I digest it, I'm going to have excrement, and that's basically what you're going to get, and that's what's going to discolor and or decay the wood. So that's kind of what happens. Now, given enough resources and time and appropriate temperature, they will start to generate fruiting bodies, sporophores or mushrooms, and we'll see that as well. And we know that when something is generating reproductives, it's very healthy. Okay, that goes for all life. Okay, so here's this is kind of cool. Here's the 5 body parts of fungi. If you're ever on Jeopardy, if you need a really cool Scrabble word, or you just want to impress the ladies, guys, here's some really good words to remember. Now, the ones that are big in yellow, we're going to see these regularly. We're going to see mycelia, and we're going to see sporophores. I'll demonstrate. You're probably not going to see spores unless you capture some and put them under a microscope and you have to have a really good set of eyes and some reasonable field optics to see a single hyphae. The hyphae band together and gang up to become mycelia anyway. So you're seeing hyphae, you're just seeing a grouping of them. And then finally, a rhizomorph. Now, a rhizomorph is basically going to be a massive mycelia that actually pumps water, or a taproot. Now, if we're dealing with the poriorots or the dry rots, I hate that word, or the water conductive fungi, you're going to see rhizomorphs because they're going to go seek water from a water source, and they're going to pump it to a dry spot. That's kind of the prerequisite to get a dry rot, or again, a water conductive fungi. So we're really not going to talk about that much because, again, based upon literature I've read and speaking to Dr. Jeffrey Morrell from Oregon State University, who's one of my mentors, he's like, Alan, I'm just not seeing porias in structures here. It's once in a while, but it's typically in my field studies I see them. We know they exist, but we just don't see them in the building. So don't worry about that too much. And by the way, if we can stop the water, we're going to get the poria in the same way we're going to handle the other decay rots. So here's a good example of some mycelial fans. And this is some of that old growth lumber. This is probably at least 100-year-old milled lumber in a crawl space in Santa Fe, not far from the state capitol. And this is subterranean, and we've actually got water encroaching through an adobe foundation, which is off to the left there. That's actually simply mud block and brick, and the water's encroaching through. That's why we've even got the mycelia on there. But if this was new growth timber, some pine, that would have been obliterated. And you'll see that in some of our other examples coming up here in a few minutes. Here we have, again, this is actually, again, some of that newer growth, a pine, totally different situation. Now, this house sits high and dry. What I mean by that is we don't have any moisture coming into this crawl space, into the wood directly. We're getting what's called rising damp, which you guys in the eastern part of the United States are probably really familiar with, where basically you're getting a thermal inversion inside the crawl space, and it's getting all the wood damp, and therefore we're getting fungal growth and decay, etc. And so this one, it's got some really interesting looking mycelial fans. And again, this is in good old dry New Mexico, 9 inches of rain a year, and we can actually see some of the moisture that those mycelia are capturing. We can see it's certainly wet because the cast iron pipe for the gas line and the anchor bolt has rusted as well. Plus, you see just a darkened discoloration of the band board / rim joist to the back of the picture behind the spider webs. As we take our nature walks, we identify this. When we take walks up in the mountains, there's a lot of green, a lot of moisture. And whenever we come across a felled log, we definitely can have a little fun taking pictures and looking at the beauty and the grotesqueness of the decay fungi that are going to exist there as well. So we've got a little bit of decay white and black, and then we've got some very grotesque amorphous mushrooms there as well. We can also look inside the heart of a tree here, and it kind of creates a pond and a collection bowl for water. And we see the more common mushrooms, the chapeau, the cap mushrooms. And I don't know what type these are. Maybe they're poisonous, maybe they're delicious. I don't know. Be careful with that. But the bottom line is that's a mushroom that we're more accustomed to picturing in our mind's eye. Okay, a toadstool, if you will. As far as structural pest management goes, I like to group my fungi into 2 groups. And again, this is all textural. It's all found in textbooks. There, surface staining fungi, some people would call it surface mildews, and then penetrative decay rots. Okay, so I want you guys to understand, at least in New Mexico, conducive conditions are always the cause of decay rot in our state. And the big 3 that I'm concerned with are going to be high grade wood to soil contact and moisture encroachment. And I'm going to double down and say, when we deal with anything other than subterranean termites and drywood termites, we almost always have to have a conducive condition in New Mexico. May not be the case, other than, again, you might consider rising damp or just general humidity conducive condition. But if we do it well, if we do construction well and grading well, we just don't create conducive conditions in New Mexico, and we avoid a lot of the problems I'm going to teach you guys about today. So surface stains really just cause discoloration of the wood, as there's an exchange of starches on the surface with the fungi. But what I want you guys to understand is that it does make that surface of that wood more available and susceptible to the decay rots, the porias and things like that. It's really important to understand or grasp why is this important to our consumers. It indicates a chronic moisture issue. If you're in a sub area of a structure and we've got discoloration, that's been allowed to go on a long time. If we have surface staining fungi outside, that outside wood's not been appropriately cultured to deal with the rains or whatever's coming off the helm. These are called viga posts. Those are beams that would support the ceiling of a home. In this case, this is a contemporary frame structure. So these are fake or faux vigas. So they're basically decorative. Yay, we do silly things like that. But that's a really good example of surface staining fungi on the wood right there. So we'll see that regularly. And we know that if that's not attended to, that we'll eventually start to see decay rots, not because surface staining fungi get promoted to decay rots, but because the conditions exist and are a bit amplified by the surface staining fungi to allow decay rots in there as well. Here's one where we had a pressurized leak in a crawl space. This is maybe a 5-year-old home, and there's a little tiny pin leak. So it doesn't have to be a lot of water. It just has to be a little bit of water over a long period of time. And we've got surface staining fungi in this crawl space. Now in this crawl space, this is moisture coming from the outside and matriculating into the crawl space because we have high grade in proximity to this. What I mean by high grade is, if you guys can see my cursor, the outside grade exceeds the level of the foundation, which is off the bottom of this image, and it's most likely up to this level. We also probably have water coming down out of what we call a canale, which is a downspout or scupper, and concentrating near this. But we're starting to see the fungal sporing and the blotchy action there. That's stuff that we see as well. Now, here's one of those conducive conditions. So this is a series of images real quick. So we've got water standing trapped right by the entryway to the crawl space. And then once I get into the crawl space, that's the condition of the subfloor. Now, if you look closely at my moisture meter, we'll notice here that it's showing 0% moisture. So even though we had a rain event the day before, and we're probably going to get some water encroachment in there, it probably takes a little time for the moisture to work its way from outside to the level of where I'm taking my meter reading. So just because it's 0 doesn't mean everything's honky-dory. We've got a conducive condition, and we've got surface staining fungi, and we know that that is ripe for some of the other pests that we're going to talk about as we go along here. Now, if we switch our gears and start thinking about decay rots, this is where the wood's destroyed because the cell walls of the wood are taken, and we have loss of structural strength. As a matter of fact, as you do your research and do reading of some of these texts that I'm prescribing to you, many of them will say that we lose more structural timbers to decay rots than we do to termites. And let that sink in. I try to teach that to realtors because they've always got they've got the termite blinders on. All they know about is termites, because we as a industry have done such a poor job explaining to them that it's not just the termites. We have to think about decay rot. And again, in New Mexico, it's always about conducive conditions. Okay. So again, a reminder, remember the white stuff in wood is cellulose and the brown stuff in wood is lignin. So what type of decay rots do we have? Well, the common descriptor names are brown rot. Now, brown rot consumes the white cellulose, leaving the brown lignin. So what happens is the wood darkens, becomes brittle, and breaks across the grain because we've lost that stringy, flexible, fibrous action of the cellulose. The cellulose has been consumed by the brown rot. We flip that over. Now, this is a less common rot that we see. White rot is able to consume the lignin and leave the spongy white cellulose. Now, I find this interesting because now you've got a fungi that is like super fungus, because the lignin in its own property wants to fight against the white rot and also wants to push away the moisture. So I find this very interesting. So it's rare that we see white rot, maybe 1 out of 200 events, or it's like one white rot issue, 199 brown rot for where I'm from. But again, remember the equation. Brown takes the white, leaves the brown. White takes the brown, leaves the white. So that's why we've got those common names. And there's scientific names, which I'm not going to get you all wrapped up about today. You can dig and do your research. I want you guys to be careful, and this is why I tie this together, because brown rot is often misdiagnosed as subtermites. So if you will look at this image that I present to you here, at first glance, without closer examination, oh, there's mud tubes from subterranean termites. I guarantee you, none of those are mud tubes, and that's brown rot. Okay, same idea here. Yeah, I see some soil there. Well, why is that happening? Because my blade that I use to probe actually is punching into the soil that's on the other side of that rim joist. Okay, terrible construction idea, conducive condition, wood to soil contact, that's obscured beneath an outside patio. So you can imagine some of the problems we're going to have to fix that. But that's all decay rot, guys. None of that is subterranean termites. Now, I do see them together sometimes, but not so much in the case of these images. And finally, this one as well. Now, what you're seeing in this image right here, that's actually concrete. So that's the concrete, but we see surface staining fungi here. This is all brown rot. Actually, we're actually losing the subfloor up here. Water's getting between that concrete, which is the outside stoop, and just keeps encroaching in there. We see it's been going on for a while. Wow, we've got all that rusty nail action there. But again, we still have tremendous loss of structural strength and value, despite the fact that in this case, there's not a single insect to be found, okay? Now, this is, not quite as catastrophic. Our outside patio covers or porch covers, we call them portals. And we have portal beams that are load-bearing and decorative at the same time, probably stuff you see in your neck of the woods, just got different cultural and geographic names. And so I'll be sounding the wood. I don't start stabbing it like Psycho or Jason or anything like that. I tap it and it sounds hollow. And I slide my blade into the hollow point to make a point on my inspections. I take a picture. And also, by the way, I like to put my moisture meter there. And we've got 60% moisture, even though that looks super dry, doesn't it? If we go back here, that looks wet. That looks wet. I don't remember the moisture contents on those, but I want to demonstrate to you with this image. Sometimes it looks bone dry and we've got a lot of moisture. Another thing I like to point out in this image, if you look closely, we've got this copper wrap collar, and all that is to hide the ugly construction work at the bottom. And I'm not blaming the contractor for doing ugly work. You just don't get a clean connection. So that's why baseboards are in most houses as well. We also like to do the same thing with stucco. We'll wrap those with stucco, but you can see the damage. And if once the stucco's peeled off, you see where the end of the stucco was at one point, we get that decay. Now, what's happening there is we're allowing moisture to get in there, and we're not allowing air movement and sunlight to dry it out. And well, the air dries out, the sunlight, the UV is going to murder the decay to some degree. So we're actually making it worse by hiding it, obscuring it with these collars, okay? Again, wood to soil contact here. We've got a cross beam connective piece underneath the deck. People walk on this deck to get into the house. So we consider that inbound for our inspection. Wood to soil contact. We've got brown rot breaking across the grain and a little bit of white rot starting right there, tied in with the brown rot. So they're not mutually exclusive, okay? This is a safety banister on the second floor. So there's no real addition of moisture. This is just new growth wood, not appropriately painted. They probably used the cheapest paint they had or what was laying around, and it decayed. My job is not to point out safety issues. I've just pointed out and put it in my report, and we hope the home inspector would quantify the safety issue as we go forward. This is one of those canales or scuppers I was telling you about. So this one's probably sitting 8, 10, well, at least 10 or 11 feet in the air, coming off of a flat roof home. And we see the damage from the decay. And then again, we've got an amorphous sporophore or mushroom right there. Now, these are wood, but they typically put tar or some sort of a metal lining inside there. This is just telling me that those efforts have failed and we're getting damage, okay? So this is a good example of New Mexico construction, more contemporary. We've got the flat roof up here. We've got that canale with it's got a metal scupper in there. This is a ramada or a shade structure. And these are what, 8, 10 inch thick beams here. And this one is being crushed down on by the weight of this one because of moisture encroachment chronically. But this is a really good image of that brown rot breaking across the grain of the wood, okay? And I think this is our last picture for this section, and very similar situation that we just looked at, but we're actually growing mushrooms between two pieces of exterior lumber beams that are used on an outside shade structure as well, okay? When it comes to white rot, this is the kind of stuff that we're going to be looking at. Again, it's going to be soft and spongy. It may have brown rot nearby. It may have insects. You never really know. But I just want you to see how easy that is to penetrate. And it's just smushy and soft. And again, if we had more moisture, you could usually squeeze water out of it. I've done that in a couple places, but usually it's a small amount of moisture that allowed that to occur, okay? So you can see the situation here. It's turned bleach white and it's starting to collapse. And this is all, again, due to this is a patio enclosure, and they've used the screen. This is all earth. They filled it in like a planter. And so the water is just basically matriculating through that high grade right into the wood there, okay? And again, finally, and this one, what's interesting about this picture is, look, I believe they changed this plate out because it's nice and beautiful, but then everything else has got that white fungi getting all over it as well, okay? All right, now this is not a clean segue, but a quick one. I'm going to be talking about two types of arboreal ants. And arboreal ants, to me, are identified and typified by ants that are affiliated with trees in nature. And as far as structural pest control goes, we know them to take up residence in wall voids and in actual timbers to some degree. And why is this important? Because if you have the moisture I've talked about, the conducive condition and decay, these ants do a better job. Now, we're not going to talk about carpenter ants. I believe that's been beat up pretty well by the industry. I want to talk about acrobat ants and velvety tree ants, right? And a lot of people want to argue with me and say, well, these aren't identified as wood-destroying insects. I'm like, well, by what authority? Well, NPMA 33 doesn't talk about them. That's true. But that doesn't mean that they're not bothersome and they're not causing some degree of damage. I will concede they do not cause the damage that carpenter ants or termites or wood beetles or decay fungi do. Nonetheless, they cause damage, and nonetheless, they get our clients' attention. Therefore, we probably ought to know what we're talking about. So the velvety tree ants, and this is a broad genus. So Liamatopum is the genera, and then there's several species behind there. The one in New Mexico looks like in this image. It's dark brown to black. In New Mexico, some of my colleagues in the areas where we have a lot of pine trees call it the pine tree ant. They're described in my books as generally monomorphic, but I've had some people challenge that, and I'm okay with that. I'm all right not being correct. By the way, my mentor, Paul Bello, who will be at the conference, this is one of his best sayings. I love this. The bugs simply don't read the books. So even though we write something in the book, we might have some evolving knowledge. So it's okay. So if some of them are polymorphic, I'm okay with that. But my reference guides claim them to be monomorphic. And my experience with this girl here, they've all been monomorphic. So approximately 4 millimeters in length. They have a smooth thorax with a single peak node. And if you recall your morphology lessons from carpenter ants, they're described the same way. So you're going to have to use a couple other key indicators to say, are we dealing with a velvety tree ant or are we dealing with a carpenter ant? I don't have any problems distinguishing them, but keep in mind, if all you're looking at is that smooth thorax and that peak node, okay, well, that's going to walk you right into carpenter ants as well. They have a 12-segment antenna with no club. And also, here's a key one. There's an odor when they're crushed. I spent at least 5 years of my career misidentifying these as odd odorous house ants. I thought we were dealing with odorous house ants getting up into people's ceilings and stuff like that until I came to a class and talked to somebody that knew more than me, and I had my mind changed. It's like, oh, silly me. So I like to admit that I didn't know everything, and that's why I came to classes, and I hope that's why you're here. Okay, I don't think anybody comes here to Purdue on a spoof or just to get a CEU. I think you guys come here deliberately because you want to get some of the best training. So don't let that odor when crushed thing fool you. We know that's a high indicator for odorous house ants. Also shows us these guys as well. So if we go right back to NPMA, right to the area that I'm pointing out in the circle there, they have caused extensive damage to insulation. They also damage wood, which I think is important. That's why I'm going to say, well, by whose authority are we deciding that they're not a wood-destroying insect? Okay, state of Indiana, state of New Mexico. New Mexico has nothing to say about that. I don't know what Indiana has to say. Okay, so we want to make sure that we understand if we take a look at not only our textual information, but also the fact of what we observe, well, we know that they cause problems there. This is a nice image from one of our ACE entomologists, Associate Certified Entomologist, Dominic, who's also one of our service managers. He was these hippies up in the mountains of New Mexico, and I think they like that term. They tried doing all their own pest control and finally got frustrated. And here's some still, blurry a little bit, but still images of these ants. They were highly active during the summer. And then here's a quick little video from Dominic. So that's Dominic telling you a little bit about that. And this house is just littered with bodies and debris being thrown down from the ceiling of this house that people are frustrated. And that was one of our tougher challenges. If Dominic's getting involved, it's one of our tougher challenges. This one comes from one of my young ACE entomologists up in, he's now moved to Oregon, Jonathan. Thank you for the image here if you're listening in. But there's that debris field from velvety tree ants. And here's a still image now. You'll see these animals, these ladies look a little different. These guys are red and black, and maybe if you look closely, you see a little bit of polymorphism, perhaps, maybe that. But the bottom line is they behave the same way. They behave very similar to acrobat ants and carpenter ants, and a lot of your remedies are the same. And this is not a remedy class. It's not a control class. It's an identification and biological understanding class, okay? So moving on to the acrobat ants, Chromatogaster is the genus. From my research, there's at least 30 species of chromatogastro in New Mexico and maybe up to 100 in North America. So what we're looking at is we look at this animal, they're monomorphic. This is true. Their colors are going to vary. We typically see red and black and fully black. I've seen yellow. They're approximately 4 millimeters in size, so roughly the same size as a pavement ant or a velvety tree ant. We will identify spines in the last thoracic segment. The nodes are 2 nodes flat attached to the top of the gaster, which is actually very unique in ants. We don't see that very often. We have the 3 segmented antenna with 3 segments at the club. And if we look at them from the top down, which we'll demonstrate in a picture here, is that we have a very distinctly heart-shaped abdomen. I think this is the first ant you teach people to identify because it's easy to identify. Going to the field guide, okay, inside structures, acrobat ants typically nest in wood that has been subjected to high moisture and fungal decay, which is the same as favored by carpenter ants and other things we're going to talk about. They also nest in foam, insulation panels. So the whole point of that is that I've talked about conducive conditions, moisture, and decay. That's what draws in these animals. They take advantage of decay weakened and moisture weakened wood. So we need to kind of put this all holistically together. And that's why I've done that in this class. There's that image. This is my personal image in a crawl space from about 3 weeks ago in Santa Fe, New Mexico. We had them trailing. They weren't doing any significant damage, but some debris was being thrown down into the main living section. So we reported on it, recommended some ant control, and we went from there. And again, here's a video from one of our technicians. I believe I'll give credit again to Jonathan Nahara. So he's shooting a video through a hand lens on his phone. And so we have the acrobats actually taking chunks of wood out of their gallery in a tree and throwing it out. And so they're proving that they cause damage to wood. And again, it may not be super significant, but nonetheless it occurs, and we should be mindful of that and keep in mind how we take a next step in recommendation and control. Here's a debris field that these acrobats caused in a home. This is one of my inspection pictures from the mountains east of New Mexico. So I'm on the other side of that mountain that I showed you. And there they go. And so we see this, and it's something we see routinely. We get a lot of phone calls going, oh, we've got a termite problem. And what's going on? They send us a picture. No, that's certainly not termites. It's one of up to 3 different species of arboreal ants. We know how to handle it. Here's how we do it. Now, let's go ahead and move on and leave the ants behind us and spend the rest of our time together talking about wood infesting beetles. And I'm not going to read this list here. You guys can read it for yourself, but this is something you should drill on. If you get involved in wood insect management, inspections and consultations and whatever it might be, you should know these 7 families, and you should understand how each of these behave differently. Now, we're not going to get into that. We're going to only talk about 2 of these beetles today, 2 of these families, and we're going to drill into them a little bit. Now, we're going to talk about the anabiids, which have been renamed patinids. So any of the big shot entomologists, the guys with the PhD after their name, I know you guys get together and conspire to change this stuff. And I'm sure there's a reason, but it's probably the same reason we kicked Pluto out as a major planet. So I'm okay you did it. I'm not going to hold my breath and die on this one. But if I use the term anabiid for the rest of my career, y'all have to just live with me because that's what you taught me first. Okay. We're also going to talk about curculionids, which are going to be the wood weevil. That's a mouthful. And we're going to drill down into a specific subfamily as we get to there. But let's just take a look real quick. Now, again, here's that map again. And all I did is I added some red dots based upon the case studies, and it's going to be 1 or 2 images each of the homes I'm going to talk about for the remainder of this class. So I want you to see where these happen. So we've got something in the mountains. This actually is not mountainous at all. This is actually just high savanna, which is going to be sagebrush and cactus. This is going to be urban Santa Fe, not far from our state capital. This is going to be definitely in the mountains, probably about 9,500 feet. A lot of water, a lot of trees, most likely a local infestation locally. Same thing with this one. And these happened in urban Albuquerque, not far from downtown Albuquerque. So doesn't really matter where you're at, you can run into these beetles. So according to the textbooks, the moisture content requirement can be as low as 13%. That's not a lot of moisture. That's like a drought in Mississippi. All right. In New Mexico, if we're getting 13% in the water into wood members, either it's outside wood that just got rained upon or there's something wrong. So in our area, we're very lucky knowing that if we've got raised moisture content, there's a structural flaw. And we can probably say, okay, how do we get that fixed? Now, you guys with a lot of high humidity, you don't get that luxury. But keep in mind, they don't need a lot of moisture to be successful. So for example, here we have some of our wood weevils. Now this is not my best image. This is simply an iPhone picture in a crawl space. Hopefully on this guy, you can see that snout, because these are like 2mm beetles, by the way. Okay. And right near them, I decided, let me meter the wood to see if we've got the right conditions. And sure enough, we're at 14% moisture content. So, aha. This is my drawing from that inspection. And we had issues with moisture coming in. We had high grade, so we were getting moisture encroachment here. And I forget what these numbers were, but bees or beetles, wood to soil contact. We actually had some termites in that one. What I didn't write here was my moisture content because I had the picture, but 2 and 2 makes a wood infesting weevil infestation. Now, in this case, we didn't find anything besides those dead weevils, but I know where they're living. I know they're not living in the grain in the cabinet. I know they're not, those are not domestic beetles. Those beetles are wood infesting weevils, and we've got to get moisture control in this house, or else we're going to wind up with a bigger problem. So let's first go back to anabaeids and talk about them. This is a really great, like super macro photography by David Mora del Poza. He's my Facebook buddy on Pest Cemetery. He works with Anti-Samex in Spain, and he gave me permission to use this. I think this is such a wonderful picture of the furniture beetle, Anabaeum punctatum, and just what a wonderful image of that. And these beetles, if we look at them top down without aid, they're just very scarabby looking, kind of oval and rounded there. So again, going right back to the textbook, exit holes are round, and depending on the species, will range from 1/16, which is pretty small, to 1/8 inch. Typically, I see the 1/8 inch. Another indication is of an infestation is the accumulation of piles of powdery but gritty frass beneath the exit holes or streaming from them. Okay. Now here's an example. This is that same house I showed you the acrobat on a few moments ago. I'm coming around and I'm sounding the wood, and this wood just kind of cracks and chips under my blade. And if we look into this picture, hopefully you've got a big enough screen. I know if I blow this up on a 12 or whatever foot screen I'm going to be blessed with live, you're going to see the frass, but you're going to see the little bun-shaped pellets that are described in the literature. But what I found interesting about this one is we don't have any exit holes. So I believe we had infestation prior to installation, or we had an infestation early in installation of the wood. Now, this is about a 60-year-old home in Santa Fe, 60-year-old home in Santa Fe. And I think they stopped the moisture because I metered the moisture. We had 0 elevated moisture. So I believe that this just stopped. I believe this self-medicated, it self-alleviated itself, okay? So that's one thing we may see, okay? Here's another one for you guys. Now, this is in dry Santa Fe. This is an area where we wouldn't expect a problem. They just did a terrible job with drainage and water flow off the flat roof of the house. And this is just obliteration of the lumber by anabaeid beetles. This was a complete tear out, guys. Absolute nightmare for a real estate transaction. This one took 13 months to go from the day of inspection to when they could finally get it sold. Same house. I'm about 40 feet away now. And if you take a look in this image, I saw some exit holes there, some exit holes in the plate, some exit holes on the rim joist, but we see the discoloration from brown rot. And then of course we see the damage from the anabaeid beetles, which again, I'll demonstrate with the amount of frass. And I turned off all the volume here. I wasn't really happy with my narration in the crawl space, but you get an idea of what's going on. So we've got a significant problem in good old dry New Mexico. So imagine, again, everybody talks about termites. I always wonder, how often are we running into these beetles that we should keep our eyes open for it? Okay. This is another one. Oh, I've actually got sound on this one because I want to hear the wood crack. But this is a cabin about 9,000 feet. They allowed water to rivulet underneath this cabin. This cabin was built in 1956. I got the whole story. The lady was super curious. The phone call came in. I've got a termite problem. When she told me where she was at, I'm like, I don't argue with people on the phone because I don't really know, but I'm like, yeah, you probably have a wood beetle problem. And sure enough, I was there for about 90 seconds and I figured that out. And this again was a complete and total floor tear out. They had to empty the cabin of all the household goods, put it in a storage container, and then redo the entire floor. And then we treated all the lumber with Boracare. Okay. This is another one up the way. It's on I-25 past Santa Fe towards Las Vegas and then up onto Colorado. And here we have, again, a very typified anabaeid exit holes there and there and there. And then this is basically the image shot from the side. And here I am underneath the stair stringer. I had to climb down this into a root cellar. So I'm actually surprised I didn't go through this stair set coming down into the crawl space area. So I don't always run my blade through stuff like that, but if I can, I do, so that the clients can say, well, how bad is it? And I'm like, it's that bad. What should we do about it? Well, if my blade's through a piece of 2x4 or 2x8 or whatever that is, probably replacement makes a lot of sense, but that's not my call. I'm just showing you what I found today. Okay. So let's move on. And this is the last section of the class today. So we're getting close to the end. I appreciate you guys hanging in there with me. And again, I hope I've inspired some questions. And so take an opportunity to jot a couple down. And obviously, if you're virtual, you'll have a chance to notate them. And then I'll be live with you guys in the studio there at Purdue. So infestations of the subfamily Coccininae as observed in central New Mexico. So these are going to be kind of the snout-nosed beetles or snout-nosed weevils that I showed you earlier. I'm just going to drill in a little bit closer. So for the taxonomy, order Coleoptera, family Curculinidae, subfamily Coccininae, and then the genus and species are broadly various. In my research preparing for this class, probably 15 or 16 identified and captured genus and species of these guys. And I'll show you some of those today. So it's kind of an interesting little pathway. And as I read about them, if I read them in the field guide, they're identified east of the Mississippi. So ta-da, that's no longer the case. We've got enough information to probably update the NPMA field guide. Maybe there's enough people of influence today that might be interested in asking me some questions, and I can share some information with you, and we can update that so that we're not fooling ourselves if we look at our field guide there. So this is an example. So I showed you these guys with an iPhone image in a crawl space, getting as close as I could and then zooming it in. This is under I have a Dynolight. It's not the best microscope in the world, but it's pretty darn good for digital. So these are drawn up about 300x. And what you can see is we have the snout, we have the antenna attached to the snout. We have a highly punctate or pitted pronotum, and the same thing with the elytra, highly lined up and punctate there. And that's going to be typified by the entire subfamily. Is it looks like this. Now they're going to vary in some other morphology, but that's what we're looking at. Okay. And right out of the field guide, and there's very little literature on these guys. That's why I want to teach about them, because I don't think we have a lot to go to. And exit holes are raggedly round. That's important. Raggedly round. That adjective is really important. About 1/16 of an inch. So they're smaller than anabaeid holes. They're elongate and irregularly shaped with a ragged or indistinct margin. So you're going to have, it looks like somebody just kind of ripsawed it instead of drilled a hole through it. Now, there will be a couple of round exit holes, but they're pretty ragged looking. And I'll show you what I'm talking about. They attacked all types of wood, but they prefer wood that's slightly damp and partially decayed. Again, I hope you see the programmed instruction. Let's talk about moisture and conducive conditions. Let's talk about decay, even just surface standing fungi. Why? Because that's what encourages all the bugs we're talking about today. Okay. Heavily damaged wood has its interior honeycombed, and that would include sapwood and heartwood. So these guys don't mind eating the heartwood, which has got more lignin in it. So they're not driven by high starch sapwood. Okay. So here's a drawing, and the image I'm going to show you, and I find this interesting. This is an addition. Okay. That wasn't part of the original house. This is a shotgun house in downtown Albuquerque, probably an old railroad house from, I don't know, the 30s, the 20s, maybe 100 years old. And that the video I'm about to show you is that right there. We could see this happen in other areas too, but the video is right there. What I want you to see in this video is look at the color of the wood. That's not the color the wood started. So that darkened color is that surface staining fungus. And then these beetles were more than happy to take advantage of that. Going back to this slide before, what's going on here? Poor drainage. Before this addition came in, probably poor drainage. So we probably had a situation where that occurred long before that was even installed. Okay. That's what we're looking at there. Okay. So here is one of the first times we captured this beetle. I remember being in a crawl space. We saw these exit holes. We saw this damage. Oh, look, we've got dead beetles here. So I collected them. I didn't know I said, it doesn't look like an anabaeid. It doesn't have that scarab shape. This is kind of odd. Let me grab this. And so I brought it in, and this is the image. And this image hit Facebook Pest Cemetery. And I just asking questions. And this is the guy that replied. If you guys don't know Dr. Jerry Wagner, you should. He's retired, living in Florida. I think you guys were rivals because he's from the Ohio State University, and he worked with the company in Ohio, I think, his entire career. This is one of the most meek, wholesome people you'll meet. He loves to help. Man, I hope he's listening to this, because Dr. Jerry, I sure appreciate everything you've done for me and you've done for the industry. But here's an article that he wrote in January of 1992. So 31 years ago, right? 31 years ago as the date of the Purdue conference this year in 2023. It's hard to say 2023 after reading 1992. And he's talking about what he was running into. He's also saying, by the way, there's not a whole bunch of literature on this thing. And he was able to ask people, and he thanks them in this article. Thank you for helping me identify this. So all he's done is paid it back or paid it forward, whatever the right expression is. He did that. So take a look. There's that guy, and there's what's included in his article. Okay. One more time. Now I want you to take a look at this other beetle in the same subfamily. Little different, right? This guy's he's a little, to quote Gabriel Iglesias, this one's a little fluffier than this one right here. This one's a little bit more elongate, a little bit more trim. This one's a little more thicker. But you know what? You see a lot of the same things. You've got the snout, you've got the punctate, pronotum and elytra, and guess what? We find them in the same situation, okay? Bug Guide is a really good place online to take a look at stuff where people post their findings. So you can take a look to the left, Hexarthum ulcaei. So that's Hexarthum ulcaei. I forget the name of this one. It's not that important. I'm comfortable being at, first off, wood-infesting weevil. Second off, subfamily Coccininae. I know how they're going to behave. So here's Hexarthum ulcaei. Matter of fact, this one was captured and identified in 1963 in Indiana, Tippecanoe County. All I know about Tippecanoe County is Tippecanoe and Tyler too, some sort of presidential slogan from the 1800s. We also have other of these snout beetles. We have the Rhinoculus bruneus and the Tomulus quericola. So we have a broad genera and species list, but they all behave the same. And that's what I want you guys to gather from this class today. So we're looking for damp wood. We're looking for sort of discolored fungi-ridden wood. Then we're going to be looking for the things I'll show you in these videos, okay? I want you to be looking for these things or these still pictures. Take a look at this stuff. I want you to keep in mind, too, what makes them unique compared to other wood-infesting beetles is the adults are known to feed on the wood alongside the larva. With our other beetles, we know that, like the anabead beetles, the adults depart after they relay their eggs in the reinfesting situation. They depart, and they typically go feed on pollen or nectar, and they leave. So you may not find as many. These adults hang out in the crawl space, so we tend to find a lot of bodies, at least in my experience, okay? And this, again, is from Jonathan in Oregon. From what he tells me on this, I love stories. Why were you there? I certainly wasn't looking for these, but I happened to find this. So the customer had more problems than they thought they had. So he's got the adults alongside the larva, and there's the larva inside of some of the wood that he was taking a look at. So thank you for those, Jonathan, and I sure appreciate it. Okay, this is our lead inspector, Rhett. And what I want you to see in this image, I'm in a crawl space. All that wood looks all weathered and weird looking, right? Whenever I see something weird, I've trained myself and I train my guys and the people that I would consult with. If you see something weird, you better go touch it. You better probe it. You better tap it. You better get close and take a nice, clean, tight, close picture. So Rhett did that. He's got a pretty nice picture here. Our field of vision's close on the base of the sill plate, but you can see kind of blurry. We see the rim joist in the back and some of the subfloor. But if we zero in on the plate, what do we see? We see that ragged, honeycombed, irregular stuff going on there. Maybe that's an exit hole, but look who's hanging out there. We have all these beetle bodies. So that's the kind of stuff we need to be looking for. And you got to slow down your inspections, and you got to beware. All right, when the wood looks in this condition, we should be looking for that pest as well. This is another one, same location. Again, we can see the raggedness back here, a couple exit holes. There's some beetles there. But in this case, we actually have subterranean termites. There's the mud tunnel. And they're based on the same conducive condition. On the other side of this, we have high grade and moisture encroaching into the wood, and the termites are punching in laterally from beneath the exterior stoop. So we can have both. And again, although this is not a treatment class, the control measures are absolutely different. So we've got to keep that stuff in mind. Hopefully someone else will teach you that, or maybe I'll teach again for you guys another time. And this is an interesting video. We're actually here to treat this home, and this is a house in downtown Santa Fe. This was supposed to have been repaired before we got there. So the whole point of this video was I'm down there teaching a guy how to do a borer application. And he's like, hey, dude, we got a problem. I says, what? And he says, they didn't do the repairs. Now they did some of the repairs, but they didn't finish them. And what I'm really narrating in that video is that wood is not in no condition to be treated. We know boric care is going to move through the wood fiber. It's going to use that same action that where moisture moves through the wood fiber, right? Well, the boric care product mimics that and just moves slowly through the wood. Ain't going to happen if you got nothing but frass. Okay. Hopefully you also saw in that video the honeycomb nature and just the absolute obliteration that these wood infesting weevils do. Okay. And now this one, I keep this video because I misidentified this because I wasn't aware of these weevils. Okay. And so I just said, oh, we got an anabaeid beetle problem. And again, if you read the literature, it says it's a lot like anabaeid beetles. So I'm going to admit to you guys when I got something wrong and why I bothered to teach this class and why I want to evolve and go, yeah, I didn't get that right. Now, was my misidentification catastrophic? No, because I was really close to the target. Okay. And my recommendations to halt the infestation and make treatment would have been the same no matter what. So it didn't cause us any grief. It was the right prescriptions to make, even though I dared to go beyond and said, hey, this is anabaeid beetles. I just know more now. Why? Because Dr. Jerry Wagner helped me understand that. And we actually did a decent collection. I was actually able to recover some bodies, microscope them, and then get the help. Pest Cemetery wasn't even on my radar. This is like a 10 or 12-year-old video. Wasn't even on my radar when I did this. I didn't know these helps were out there. So there's some, I think Pest Cemetery and stuff like that, these are informal helps, but there's a lot of high-level professional people with a lot of knowledge on there. So I think we're coming to our end of our time today. I will remind you again, conducive conditions are always the cause of wood beetle and wood decay infestations in New Mexico. So that's our situation. Obviously, I don't live where you live, so you ought to consider all those things as well. I'm going to end right there. I believe we've got the time pretty close to an hour here or 50 minutes. And that's my contact information. I will see you guys on the live Q&A session if you choose to join us. I'm looking forward to it. I don't know how much time we're given, but I won't be in a rush. So I'll be more than happy to spend time with you guys. I really thank you. God bless you guys. Feel free to reach out to me. Send me an email, send me a text. You can call me. You'll get my voicemail. I will call you back. I love our industry and I love the people in it. So, hey, have a great winter and let's pray for a nice spring. And I just pray you guys have a great pest control season. And I also pray that what I taught you today was of great value. Take care, guys.